So I think that we have enough people for the quorum of this dissertation council. Yeah, dear members of the dissertation council. So according to the order number 1.10225-1 of SD University dated April 1, 2022 and July 17, 2024, the permanent composition of the dissertation council for the defense of dissertation of the degree of philosophy of Doctor of Philosophy, PhD, in the field of 8D06102 computer science and the specialty 6D070400 computer engineering software at SD University has been approved in the number of 4 members. The chairman, Bogdan Vladimirovich, the members, Zhamanov Azamat Maratovich, the members Al-Hadith Mohammed Ala Farhil, and the dissertation council's scientific secretary, Dana Utbayeva. And plus, for this dissertation, the meeting of the dissertation council for the defense of dissertation for the degree of Doctor of Philosophy, PhD in the field of 8G06102 computer science and 6D070400 computer engineering software on December 30, 2024, regarding the review and acceptance of Meraryslan Meraliyev dissertation for defense permanent members of the council in accordance with the requirements of the regulation on the dissertation council of SD University appointed 3 temporary members of the dissertation council. The temporary members for this dissertation of Meraryslan Meraliyev are Bahjan Akhmetov, who is Doctor of Technical Science, Professor of the Department of Information and Informatization of the Education of Bayern University, Mansourova Madina, Candidate of Physics and Mathematical Science, Associate Professor, Head of the Artificial Intelligence and Big Data Department in KazNU, named after Al-Farabi. And also Ismailov Nurjigit, PhD in Specialty 6D071900 Radio Engineering, Electronics and Telecommunications, Associate Professor in the leading researcher of the IBM Lazbekov Institute of Mechanics and Engineering of the Science Committee of the Ministry of Science and Higher Education of the Republic of Kazakhstan. Okay, so the present at the meeting, we have 3 here. 1 should be online. Can you show the list, please? Yeah. So we have Azamat Jamanov. Yes. Is reviewer Mansourova Madina, right? Yeah. And Nurjigit Ismailov. And also so Bahtan. Okay. Had some issues, but we have a quorum. 1, 2, 3, 4, 5, 6 people already. So, of the council absent from the meeting, we'll see. So, if the quorum following the meeting is met, so let's begin. Okay, among them, the considered nature of the station under review, we should have 3 meetings deemed legitimate, right? It is proposed to begin the work of the dissertation council meeting. Are there any objections? Can we begin? Okay, no objections. Thanks. There is no objections, so we'll begin the work of the dissertation council meeting. Today's agenda is the defense of the dissertation of Meraryslan Meraliyev on the topic of neurocombinatorial optimization for vehicle routing problem with drones in the specialty 6D070400 computing systems and software. The work was carried out at the SD University and is presented in the form of a dissertation work. The defense will be conducted in English. This is the first time the dissertation is being defended. The official reviewers for this work are Orkin Mamurbayev, who is a PhD in the specialty of 6D070300 information systems, Professor in the specialty Computer Science and Informatics, Deputy General Director of the RSE on the right of EM Institution of Information Computing Technology of the Science Committee of the Ministry of Education and Higher Education of the Republic of Kazakhstan. Also, the second reviewer is Lazat Ilipbayeva, candidate of Technical Science, Associate Professor of the Department Radio Engineering, Electronics and Telecommunication in International IT University. The scientific consultants are for our candidate Aygerin Bogarbayeva, PhD Assistant Professor at SDU University, and also External Supervisor Fuat Hajiyev, PhD Assistant Professor at Ada University, Baku, Azerbaijan. Are there any questions regarding the agenda? Okay, no questions. If there's no questions, no objections, I request the approval of the agenda. Who is in favor of this agenda? Who is for the starting this dissertation? Okay, no abstentions. The agenda is approved by open vote. The speech is given to the academic secretary of the council meeting, Dan Utbayev, to review the personal documents of the candidate, Meraliyev, Meraryslan Meraliyev, and their compliances with established requirements.
Thank you. Good morning, dear committee, dear guests, and so for the defense of dissertation today, today's defense, Meraliyev Meraryslan Meraliyev has given before one's application. It was withdrawn by the rules of dissertation council rules, the part 35, and later he has given his application one more time, and we have two applications of Meraliyev Merariyslan, and second, he has submitted his review from this domestic scientific advisor and from this foreign scientific advisor, and positive conclusion from the Department of Computer Science at SDU University, and he has submitted dissertation in electronic and hardcover with in three languages abstracts, also a list of scientific publications certified by the Vice Rector of our university. Also, he has submitted his certificate from National Center of State Scientific and Technical Expertise, confirming the absence of plagiarism in the dissertation based on the comparative analysis with the database of NSSTE. Also, he has submitted notarized copies of his higher education diplomas from bachelor and master degree from the specialty. Also, a copy of transcript confirming completion of the PhD program at SDU University under the education program 6D070400, Computing Systems and Software. Also, he has earned the required academic credits under ESDS system. Also, order approving his dissertation topic because he has changed his topics. Also, all orders are here, and conclusion of ethics committee of SDU University. Also, information about a PhD candidate. Also, personal record sheet. So, all the documents submitted by the candidate are complete and comply with the requirements of the Committee for Quality Assurance in Science and Higher Education. So, we can continue today's meeting.
Okay. Any questions regarding the documents to our scientific secretary? Anyone? Okay. There is no questions. Thank you. So now the floor is given to the candidate for the presentation of the main points of the dissertation. Please proceed. You have like 20 minutes for the main topic. Okay.
Thank you. Good morning, dear council members, reviewers, supervisors, and guests. Today I'm going to present my research titled Neuro-combinatorial optimization for vehicular routing problem with drones. This work that was done under the supervision of Dr. Aygerin Bogarbayeva and Dr. Fuat Hajiyev. This work also was done as a part of the project funded by the Ministry of Science and Higher Education of the Republic of Kazakhstan with individual registration number AP19575-607. And I want to start from explaining from the introduction. So, as far as we know, in 2020, the COVID-19 pandemic started, and during that pandemic, during the lockdown, there was no chance to purchase the products, goods as we normally used to in the shops offline, and this is the time when the e-commerce and online delivery had a significant rise in demand. During that time, the delivery systems had faced a lot of troubles where the classical models could not keep up with the increasing demands. And this is why the new methods started to be developed. And in order to solve this problem, the vehicle routing problem was used. The main idea of the vehicle routing problem is that it represented as the complete directed graph with the set of nodes where one of the nodes will be the depot, so the place from which the goods will be taken and then delivered to the customers. And all other nodes will be set as customers. Also, we have the edges, which are the roads between the depot and the customers and between the customers. So the main idea of this formulation is to construct the roads with the minimal total cost for some n number of customers, and some different constraints could be added, such as the capacity, limited capacity of the trucks, and the time window constraints when we state that the products should be delivered in the specific time range. And as an extension of this problem, the vehicle routing problem with the drones were introduced, where the UAV was used. Unattended aerial vehicles were introduced to deliver the goods in the places where the truck will take more time to deliver. It's also represented as the complete direct graph with the set of nodes, where one of the nodes will be represented as a depot and all other nodes will be represented as customers. We have set of edges which represent the roads between the customers and between the depot and customers. The main idea of this formulation is to minimize the total operational cost for a fleet of trucks and drones, making sure that all the customers are served efficiently in the shortest amount of time. Different constraints are also added here in the BRPD that reflect the realistic routing challenge, such as the capacity of the drones, capacity of the vehicles, time windows constraints, the battery life of drones. And in order to solve this problem, like the main problem that we are trying to solve are the optimizing the fleet roads to ensure efficient deliveries by creating the deep reinforcement learning framework, and to make sure that to create an algorithm for efficiently managing communication between multiple vehicles and drones to streamline operations. The main aim of this research is to develop a comprehensive naval combinatorial optimization framework that integrates drones into the vehicle routing problem to improve the logistical efficiency and the adaptability in urban environments. The main objectives of this work is to design the Markov decision process framework and develop a reinforcement learning model based on this framework for efficient deliveries. And second objective is to develop an algorithm that ensure effective communication and coordination between multiple groups of vehicles and drones, enhancing logistical efficiency. While doing this work, the literature review was conducted. More than 130 papers were reviewed, and during this review, the most relevant papers were chosen. Like the papers introduced here are, most of them solve the vehicle routing problem, and only some of them can also consider the drones in their work, such as the papers introduced by Liu et al., the papers written by Bogorbaeva et al., Shermer et al., and only one of them implements the deep reinforcement learning framework with the drones, but it's done by Bogorbaeva et al., but in their work they introduce only single drone. They do not consider the multiple vehicles and multiple drones, And this limitation also do not face the real world environment where we have the set of groups for vehicles and drones. And in order to overcome these limitations, we introduce our solution where we consider multiple vehicles and multiple drones using deep reinforcement learning framework. So during the literature review, we also introduced the new taxonomy of the methods, learning methods for routing problems. We have classified these routing methods into end-to-end and hybrid methods. For end-to-end, we also classify that to the supervised learning and reinforcement learning approach. And for hybrid methods, there are two different approaches when the learning methods improved with the heuristics or meta-heuristics, and the second approach were the learning methods for estimation with heuristics. And for key papers that are taken as state-of-the-art for our work, we consider the work implemented by Bogorbayev et al. In their work, as I mentioned before, they introduced single vehicle and single drone, and they do not consider the constraints such as the battery life of the drone and the capacity of the drone. And here you can see the example of Markov decision process for that paper. Another work that are used to compare our results, to compete with, is the paper introduced by Shermer et al. In their work, they introduced the hybrid DNS search with the tabu search algorithm that to solve the vehicle routing problem with drones and en-route operations. So they developed the hybrid algorithm that improved the optimization, and they introduced the algorithm that combined multiple vehicles and multiple drones. So now I'm going to introduce our work, but I want to start from the research contributions of our work. So we developed an innovative Markov decision process framework tailored for drone integration in vehicle routing problems. We created a deep learning model that significantly improved the accuracy and efficiency of drone routing compared to other deep learning models. Also, we introduced a new reinforcement learning algorithm that was efficient to keep the communication between different groups of vehicles and drones. And in order to start to test our model, we started with the data generation as the source. We used the data set, well-known data set from the literature, which was first proposed by the Agats et al., which has widely used and adopted for VRP and VRPD research. The main statements for this data set is that the customer locations are generated using the uniform distribution with the range starting from 1 to 100. This method ensures that customers are spread evenly across the entire operational area, simulating a diverse set of delivery points. And the pod location is placed using the uniform distribution within the range 0 and 1. This guarantees that the pod is always located in one of the corners of the operational area, which influences the routing strategies for vehicles and drones. So as simulation parameters, we consider the speed ratio, assuming that the drones usually travel twice the speed of the track, and this assumption is denoted as alpha. This assumption is consistent with the literature and reflects the relative advantage of drones in terms of speed, particularly in last mile delivery scenarios. And for comparative analysis, we use benchmark data set that has been widely used in multiple studies, including the studies introduced by Bogorbayev et al. And Shermer et al., allowing for direct comparison of the proposed approach with the existing methods. Now I want to introduce our markup decision process formulation. Markup decision process formulation states for iteratively improving the policy of defining the next actions for our framework. It consists of state space, actions, the transitions, reward, and time horizon, stating at which time step we are currently. We have introduced our markup decision process formulation. In this work, we introduced the state, which consists of the vehicles and drones locations, remaining times, the battery levels for drones, the load status of the drones, and the list of served customers at time step t. Next one is an action. For action, we consider the truck's next destination, drone's next destination, and we also cover the drones that are in transit. And action space representation is the following. The transition function describes how the state changes after taking an action. Usually it happens when the fastest truck or drone finishes its action and reaches its destination. We update the remaining times for each vehicle and drone, and we update the total time used to cover all the vehicles and drones. Also, we make the battery update when the drone is reaching the depot or the vehicle to which it is assigned. We set the battery to the maximum. Otherwise, we just subtract the distance that is taken for drone to travel. Then for load update, it's also updated as following. So when the drone is reaching the depot or the vehicle, we set the load to maximum. So which means that the drone has taken the new parcel to deliver, and if it reached the customer location, it means that the parcel was delivered, and the load will be set to 0 again. So reward function usually is the make span, which is set as negative reward because the goal is to minimize the total time spent, and for markup decision process, we usually use to maximize the reward. And in our case, reward will be the negative of the total time spent to deliver the parcels to all the customers. That's why when we set it to negative value, this would guarantee that the fastest delivery will have the highest reward. And the policy usually in our work defines the strategy for selecting actions in each state to maximize the cumulative reward, which is in this case means minimizing the total make span. So the objective of this policy is to determine the best routing decisions for all vehicles and drones to serve all customers in the least amount of time. And this is the representation of our markup decision process with examples how the delivery happens on each state. And this is the proposed deep learning model which has the transformer-based architecture. It consists of encoder and decoder. And encoder usually used to encode the current graph information, the nodes information, and decoder using that encoded information to convert it into a routing policy to determine the sequence of vehicle and drones actions. The training algorithm proposed is the following. So at the beginning, we initialize for each vehicle, we initialize the initial states for LSTM. Then we reset our environment to the initial state. Then for each time step and for each vehicle, we set the action for vehicles, and that actions will be masked for the next vehicles to make the actions, and so The training algorithm shift efficiency could be seen by these graphs. So as we can see, the reward is improving, so we minimize the make span. And to evaluate the quality of the solution, the gap is calculated, which is calculated by this formula. For make span, we just calculate the difference in percentage between the best solution and our solution. For the coding strategies, we use 3 approaches. First one is greedy method, where we just select the nodes with the highest probabilities. For sampling methods, we make the computation for a number of samples, and then we store the results of that solutions, and then after we compute all the samples, we select best from that samples. And third approach is ensemble, where we get the weights for multiple models, different weights. We compute the sampling approach for different weights for a different model, for different weights for the same model, and then we select again the best solution that fits. And as a result, we can see here in the table, we can see that in comparison with other RL models, our models, RL greedy, RL sampling, and ensemble RL are outperforming the classical models, especially the ensemble one. In terms of the cost, so we can see that the cost is smaller, and the gap is around like for 8 nodes, 1 vehicle and 2 drones, the gap is 5%, and so on. So it could be better shown in the graphs. So for 8 nodes, 1 vehicle and 2 drones, we can see that our model outperforming the classical models and do almost the same as the custom sampling augmented, and only ensemble outperforming it a little bit. But when we have more agents, like for 8 nodes, 2 vehicles and 1 drone means that for each vehicle we have 1 drone. We can see that the ensemble reinforcement learning, ensemble RL, RL sampling, and RL greedy outperforming all other models. And for the 2 vehicles, 8 nodes, 2 vehicles, 2 drones, we can see that ensemble RL, RL sampling do very good, pretty similar to hybrid model sampling. And everything is changing when we increase the number of nodes. For 10 nodes, 1 vehicle, 2 drones, we can see that the ensemble RL significantly outperforms all other methods. For 10 nodes, 2 vehicles and 1 drone, again the ensemble RL and RL sampling outperforming all other methods in terms of the minimizing the cost. And for 10 nodes, 2 vehicles and 2 drones, RL greedy here takes the lead and outperforming all other methods. For 20 nodes, we had only the custom sampling augmented model, so the hybrid model was not implemented for the 20 nodes. So when we set the number of nodes to 20, having 1 vehicle and 2 drones, we can see that ensemble RL outperforming all other methods, and RL sampling have pretty similar performance to the ensemble RL. For 20 nodes, 2 vehicles, 1 drone, the ensemble RL again outperforms all other methods. And for 20 vehicles, 2 drones and 2 vehicles, there was no other results presented, so we just tested our model, and here we can see that the ensemble model outperforming and produces the best results. Additional experiments, we have conducted the comparison with the existing heuristics and exact methods, and we can see that here, in terms of the cost, our ensemble model produces near optimal results, and in some cases, like for 2 drones and 1 drone, 2 vehicles, it produces for 8 nodes, it outperforms all other methods in terms of the cost, but in all other cases, it significantly outperforms all other methods in terms of time. So, which means that this model could construct the roads in the shortest amount of time, still making the pretty good in terms of the optimizing the cost, providing the shortest path, shortest solution. So as a conclusion, I want to again state the key contributions of this work to the field of optimization and computer science. So this the theoretical innovation in the Markov decision process formulation. Then we also development of the deep reinforcement learning model and empirical validation of the results through advanced simulations. And at the end of this work, 4 publications were prepared. Second one was not mentioned in my list of publications because it was accepted like 2 days ago to the Q2 journal. Yeah, this is the references to the works, to the most relevant works. Yeah, that's it. Thank you for your attention. If you have any questions.
Yes, so let's have some discussion. Professors can ask some questions. Let me begin with the questions. You mentioned that your work is like a continuation of the work of your supervisor. Can you go back to the table of the pluses, minuses? So you say that your main work is to add the capability of multiple drones, right? So the multiple drones proposed solution. Can you outline what's your input in this work? Okay, what you have done specifically to implement this multiple drone solution?
Yeah, first of all, we updated the decoder here. Just a second. The decoder of this deep learning model to make sure that when we have the group of vehicles and drones, because here when we state that we have 2 vehicles and 2 drones, it means that for each vehicle we have 2 drones, which means that in total we have 6 agents to deliver that are making delivery. And in this case, in the original work, they used the LSTM encoding that were embedding the wall graph and the actions for the wall graph. And we proposed to separate them by the groups in order to better coordination between the groups. So we prepared the separate LSTM for each of the groups, and they are combined together. And
we mean you specifically, right?
Yeah, yeah.
Okay.
Yeah, this was my contribution. And also the proposed Markov decision process, which I introduced before, was also my contribution.
Okay. Thank you very much. Other professors, please, questions?
Yes, I have a question.
Turn on the
So you have mentioned about here about your hyperparameters. So
Yeah.
I would like to ask about your hyperparameters specifically. So could you mention here LSTM cell numbers? How many? Because you are telling here in page 54, generally, for example, your first layer is like you are starting about hyperparameters and embedding dimensions, hiding them, and you mentioned at the 3rd step, recurrent neural networks layer, like here you are showing LSTM inside of it. So first question is why you have chosen a specific LSTM? What's the base for that? You have reviewed some previous research works, or did you try empirically or experimentally about other type of recurrent neural networks? As you know, the recurrent neural networks, it has at least 5 types, yes? So what was the base for that? Also, you didn't mention about cell numbers, like specific hyperparameters. And, okay.
Yeah, for embeddings, we used 128, if I'm not mistaken.
One more time, please.
128 for embedding.
How did you choose it? Like by empirical way?
Yeah, we have tested that. And
how many times you have tried to test?
So In general, for this work, we have conducted like more than 100 or 200 experiments. Like more than 100, it's exactly that, more than 100 experiments with different hyperparameters. We also changed the number of steps that were, at the beginning we started from 500,000 iterations, then we changed that to 1 million. Also we...
So here is a question, like due to your answer. So how did you know if you are going correctly, properly, or no? How did you evaluate your model?
So usually we compute the cost and the gaps, and we were comparing the gaps with the solutions from the papers that I mentioned before, introduced by Bogorbayev et al. And Shermer et al. We were comparing with them, and also after each update, after each iteration of the experiments, we were comparing each of our solution with that experiments, and we were checking whether it's improving or vice versa.
So you, let's again repeat your answer. So you tried to start by yourself empirically. It means by yourself. You didn't you didn't consider previous research works except your supervisor, right?
Not really. As I mentioned, we have considered more than 130 papers, and in most of them, so they have pretty similar number of embeddings, like the step, the learning rates, and so when we tried empirically, we tried to test their parameters as well.
First, okay. Then you have to mention theoretical. You tried to review.
Yeah.
Then you tried to test their work with your multiple vehicles. Then The next question about your dropout probability. As we know, it can be till 50%. So was it also empirical tested 10% of your dropping set?
Yeah, sure. We have tested different values, and so if I'm not mistaken, we have tested up to 30, not up to 50.
It's written here 0.1. It means 10% of you are dropping.
These are the dropout rate that we have come up to after the experiments.
So this is your final version. Yeah. So you tried 30%.
Up to 30%. We tried tested different values.
And you concluded with 10%. Yeah. Okay. And you are here on your model, skipping connections. So why you try to skip your? What type of your vectors skipped here?
So skip connections is usually used for for dropout rate. Like while we are making dropout, we just skip some of the nodes in the neural network in order to optimize our solution and normalize a little bit the results.
Okay, thank you. And here is a question from online committee, 3 questions, and they are in Kazakh. Let me ask here. First question in Kazakh. Неліктен сіз көлік бағытын оңтайландыру, VRP және дронды зерттеуді таңдадыңыз? Бір-бірлеп қояйын, мұнда 7 сұрақ бар, жоқ, 5 сұрақ бар екен. Бірінші сұрақ. Неліктен сіз көлік бағытын оңтайландыру, яғни оптимизация деген сөз? Бұл саланы, мен түсінгенім бойынша, бұл саланы неге таңдадыңыз дейді?
Ағылшынша жауап берсем болады?
Болады, иә. Бізде переводчик, аудармашы бар.
So the main reason was that first of all, I was really thinking about the delivery systems because me personally had a lot of struggles during the pandemic that when you deliver the products, they fail to be delivered on time, they have a lot of problems. And one of the reasons why I decided to move on with this topic was because I really had an idea that this research could significantly improve and be used in the real world in the companies such as Arbuz, Yandex Dostavka, or others. Another thing was that do you remember that we have the floats when the Uyghurs were going out in the Aktau and other cities in Kazakhstan?
In South
And
Kazakhstan.
yeah, in South Kazakhstan as well. So during that time, there was no chance for the vehicles to deliver the needed products. And in such cases, I do believe that integration of drones could help to overcome this problem, to like make the delivery for that regions easier, especially for the most like needed stuff like medical things and so on.
Енді біріншіден бұл тақырыпты таңдағанның себебі пандемия кезінде өздеріңіз білесіздер, жеткізу проблемалары пайда болды. Әсіресе мысалы сол кезде мен де осындай қиыншылықтарды көрдім. Сол үшін менің жасаған осы моделім арбуз не болмаса Яндекс доставка сияқты компаниялар жағынан қолданса жеткізуді оңтайландыруды және жеткізу сапасын көтеруге көмектеседі. Екіншіден, мысалы біздің су басқан аймақтарды білеміз, апатты жағдай кезінде сол жерге адамдарға қажетті болған азық-түлік не болмаса дәрі-дәрмектерді жеткізуде қиыншылықтар туындады. Сондықтан біз осы менің дрондар арқылы апаттық жағдайларда осындай біздің мемлекетіміздің кейбір аймақтарына дрон арқылы керекті дәрі-дәрмек, азық-түлікті жеткізуге өз үлесін қосады деп ойлаймын.
Құрметті Нұржігіт Құралбаевич, сіз өзіңіз қалған сұрақтарыңызды ауызша қойсаңыз, мұнда осындай ұсыныс келіп отыр. Микрофоныңызды қосып, егер мүмкіндік болса, бейне камераңызды қосып. Сіз бізді естіп тұрсыз ба?
Жасалып жатқан модельдер өте көп әлемде, бірақтан да ол қанша килограммды қамтамасыз етеді максималды.
So, if it's okay, I can answer in English. So, this work wasn't considering the weight of the parcels of the delivery products. So, this is the goal for future research when we will adapt this for more applied, when we'll convert that to applied research. Right now it's fundamental research, so when we consider the models and the formulation, and next steps will be to adapt it for applied research, and there we will consider such constraints as the weight of the parcels, some obstacles during the drone's flight, and the weather conditions.
Қазіргі зерттеудің сатысында біз осы тасымалдауда қанша салмағын біз қарастырған жоқпыз, себебі ол біздің зерттеудің келесі сатысына саналады, қолданбалы зерттеуге жатады. Қазіргі таңда біз тек қана модельді осы есептеу жақтарын қарастырдық. Енді келесі сатысында біздің зерттеуде осы аппараттың жүктің салмағы және де ауа райдың жағдайларды есепке алып зерттеуді жалғастыратын боламыз.
There may be other committee members who would like to ask some questions.
So, thank you for your presentation. I just have like some general questions. For example, your title could be like more specific, like instead of somehow it's like more general topic. Are you going to make like, general optimization, or you will just make it like specific optimization? As I saw you are saying about max span and so on.
Yeah.
So I think it will be much better if you be like more specific in your title, so to be indicate, because
Consider that.
yeah, you are saying like optimization. So what type of optimization you're gonna make? Like one more thing also about the scope of your study and limitation. So it's also a bit like general, like it should be for your study, but here it's mentioned about like the scope and limitation for general, like some of them even about like linear, some of them about the drone, some of them about the technology, the data availability. So it should be for your study, like what is your limitation of the study, where the things that you couldn't make it, and just in order to make it like as a future research for others. So it is really very important section to be like kind of highlighting where is your border of your research.
Yeah.
So I guess.
Yeah, can
that's
I
all.
mention about
Yeah.
the limitation of this research? So the main limitation of this research is the availability of the real-world data that is adapted for vehicle routing problems with the drones. Because most of the real data are considering only the vehicles. And for the best of my knowledge, I didn't see any real-world data set that also considered the drone deliveries.
Yeah, but you have the data, right?
So we use the data from the literature, and this is synthetic data, which is generated data.
You mean the real world data?
Yeah.
This
so
is that you don't have.
yeah, this is for the best of my knowledge. We have considered a lot of papers, and there was no examples of the real world data that also considered the drone deliveries.
Yeah, but also there is like drone integration, environment impact. For drone integration, like you are already doing that work, so
Yeah.
it shouldn't be the like limit for your study because it's your study.
Yeah. Here I can answer. The main purpose that I mentioned that it's that due to the policies, if I'm not mistaken, of Republic of Kazakhstan, they have the restriction to use the drones, unattended aerial vehicles for delivery right now. But as far as I know, right now, Kaspol started to work on top of this project, so there is the high chance that these policies will be reviewed again in the close future. But right now, this was the limitation that in some countries, for example, in Europe, especially in Germany, they have the restriction to use the drones for deliveries. And this is one of the limitations for, in general, for this research area to be like used. And maybe after we prove that this could really improve the efficiency and quality of the deliveries, we can provide some recommendations for the governments that integration of drones could help to reduce some problematic areas in the logistics and in delivering, especially when there are some disasters happened.
Okay, thank you so much.
So here is written. Sorry, I have a few questions again. Sorry. So you have written on your abstract that where is your contribution and where is your supervisor's contribution? Could you explain one more time, more in detailed version, please? Because you have common paper with your supervisor. She's the first author. You are corresponding second author. And what was exactly your contribution in this reviewing paper?
In review paper, I was, me specifically, I was been focusing on the learning methods, especially the, like I mentioned this one, just a second, sorry, for this taxonomy. So we provided the taxonomy for the whole approach for vehicle routing problems. So we have the capacity vehicle problems, we have the heuristic approach, the exact approach, and they are also like, we created the taxonomy for the wall solutions, but my personal contribution was the taxonomy for the end-to-end and hybrid methods. And here we classify the hybrid methods into two approaches. First of them is when we produce the solution using the learning methods, and then we have we use the meta heuristics or heuristics in order to improve that solution, to break it and reconstruct to make it more optimal. And this approach usually reduces the time needed to produce the good, best solution in comparison with other heuristic methods. And another type of solutions is the learning methods for estimation with heuristics. And in this case, the learning methods used to predict the best cases for the next actions for heuristics. And my personal contribution was this taxonomy that we introduced in that paper, in that specific paper.
So here is, you are mentioning in your thesis, scientific novelty, that you are trying and marking a significant innovation in logistics research. So what did you mean by innovation? Could you make it more clear here with some
the introduction of the deep reinforcement learning for delivering multiple vehicles and drones. This model,
sorry, I'm interrupting you. Do you have some type of table, comparative table, that yours is innovative than previous similar algorithms or models? Do you have some comparative analysis?
so I've just considered all solutions that are considering the drones, and usually the main thing that we are introducing, that we are applying deep reinforcement learning that helps to produce the solutions very fast. After the training, after the model is trained, the solution generation will take just a second. And in real world scenarios, when the conditions are changing all the time, when some deliveries could be cancelled or new deliveries could come, the deep reinforcement learning take the lead in this case, because the solution could be reconstructed in seconds. And introduction of the multiple vehicles with the multiple drones is an innovative solution when we combine that with this deep reinforcement learning approach. Because all other, the most recent solution that introduced multiple vehicles and multiple drones was a solution by Sherman et al. And they used the hybrid heuristic method.
Hybrid with which they used which models in hybrid, their models?
They have heuristics, DNS search and taboo search. They combine these two approaches in order to produce the solutions. And if you can...
So the, one second. Dear Meraliyev, so you told that the supervisor also used the deep reinforcement learning. So what's the difference between hers and yours model?
We have introduced the communication algorithm, and we have updated the LSTM.
But it was in her case what?
As I said before, in the work of my supervisor, she used one LSTM that were covering all the vehicles and drones, because there was no need for separation, because in their work they have single vehicle and single drone. So it's more like TSPD problem, not VRPD. In our case, we have multiple vehicles and multiple drones, and when we tried to use the similar approach, our solution failed, not failed, but could not operate effectively, because there was miscommunication between drones. Because in our case, we have the groups of vehicles and drones, and each vehicle is assigned to its own vehicle, each drone is assigned to its vehicle. Which means that drone could recharge only in its specific vehicle and take the parcels only from that specific vehicle. And if we provide the wall graph to the LSTM, it will consider that they are all interconnected, and that's why it was leading to inaccurate actions. In our case, we introduced the approach where we separated them. So for each vehicle, we have created separate LSTM embedding, and this led to improvement in terms of the communication, so that our model will now define that this is the separate group of fleets, this is the separate group of fleets. So they will, our model now consider how to send the drone in order to better communication with its own vehicle, not with any vehicle around it.
Yeah, it's clear now. Thank you.
Yeah. Thank you.
Maybe. Okay. Maybe other questions from our online committee members? Jamanov?
Hi, can you hear me?
Yes, please.
I actually was interested in limitations. Those questions already covered, and I was really interested how it's going to be implemented. Meraryslan and his supervisor had a test on computational power, like what
Ah.
kind of frequency do you use,
Yeah.
etc.
Sure, thank you for the question. So we've utilized 10 GPU-based computers. Each of them was having the Core i9 14th generation CPUs, 128 gigabytes of RAM, and some of them had two NVIDIA RTX 4090 and 3090 video chips. And we were utilizing this equipment in order to compute our solutions. Also, we, at some point of our research, we have requested access to the equipment of Nazarbayev University, to their servers, GPU-based servers, and we also use them to train our models. In general, each training took, like at the first steps when we just starting to test our hyperparameters and steps, each training took like 2 or 3 days. And after we have found out the best fitting hyperparameters, we started to play with the number of iterations, and starting from that moment, each training took around from 5 to 1 week. Yeah, from 5 days to 1 week.
That was my question. Thank you for
Okay, thank
Yeah.
you.
And about the limitations and future works, right now we are planning to integrate some GIS technologies in order to get the locations of the customers and the depots, so the places from which the delivery systems.
Which technologies?
GIS, like the maps. Yeah. And in order to get the location of the customers and using their APIs to consider the different roads, and yeah, this is the idea for future research to make it applied. Yeah.
Thank you. If we don't have any questions, we can proceed with next stage. I give a speech to domestic scientific advisor, Dr. Yerim Bogarbayeva, for her speech. Can you remove the screening shoulder? Thank you. Dr. Yerim Bogarbayeva. Your microphone is off.
Maybe we'll change the order.
Okay,
That's all.
so let's communicate with Yerim Bogarbayeva, but let me give to the next person who is a foreign scientific advisor, the professor from Azerbaijan, Fuat Gajiv. Please, floor is yours.
First of all, thank you very much, everyone, for participating in the very important meeting, important for all of us, and first of all for the career of our young researcher. Thank you very much. And regarding my speech, I'd like to start with, I think this is very important for me. First of all, I'd like to thank the members of Academic Council and the guests for asking so many, really so many very good questions to candidates. At that point, so I have no more questions because so many questions and really great questions. And I think that each answer that a candidate should have begun with gratitude to the person who asked the question. This is a small ethical remark. And so regarding my report or my review, so actually you have the review of Meraryslan work that I have submitted, and I certainly believe that the author of the dissertation deserves to be awarded with PhD title. Regarding the work itself, the dissertation itself, so I think that it's an independent work. Yes, we have a supervisor, local supervisor, it must be. And it's a standard way that usually any supervisor just some task from his own research area. It's absolutely normal. And so again, I'd like to highlight here that point that work is highly independent, and in my opinion, its special value is that first, it's a rigorous scientific work based on fairly deep theoretical part, and has an obvious possibility of being applied, not just to the case which mentioned author of this dissertation, but to many logistic problems. And not just in many directly logistic problems, many indirect in various formulations. Maybe it's not the problem, it's not direct logistic problem, but it can be reformulated as a logistic problem, as we have in many problems in economics that can be reformulated and then solved by different optimization method. Can be reduced to the standard models or to the combining of standard models. So I especially, I'd like to especially note at that point that the following characteristic of the author of the candidate. The first is excellent theoretical base. He knows from my discussions, my observations from discussions, many time discussions, online, some task, offline, when being in Almaty. We discussed many times the theoretical part, especially of the work, and I discovered really the deep knowledge, especially math knowledge of the dissertant. It's very important, because if you apply some model, so if you want to, for instance, especially combine different models, we have to have a high mathematical background to combine the model, and the ability to work with various models and methods, and the ability to stitch various models to obtain much more effective result. It's one of characteristics of the dissertant, which really I can observe, or I observed during my meetings with Meraryslan. And regarding my conclusion is, believe me, is expectable, absolutely expectable, and I think that I believe that conclusion from each reviewer must be the same, that remarks. So of course, I'd like in that point maybe to mention some specific, maybe specific points which can be done in more detailed form. But again, I'd like to emphasize that so many questions we had today to the dissertant, and my actually my points in that for the dissertation regarding the remarks, actually it was done, it was answered, and I'd like just point out at this here at the end of my speech that remark that I have, or that many questions we had today, doesn't reduce the value of the result obtained, which have the scientific novelty,
more or less it no matter, we have, and practical significance. It's important also. Practical significance, as I mentioned at the beginning of my speech, that it can be done, I mean application can be done in absolutely different formalizations which reduce different problems to the logistic problems. And so dissertation meet the requirements for the doctoral dissertation in the specialty of computer system and software with some years we have 6D 0704000. It's but the name is computer science as computer system and software. And the author, Meraryslan, of course, is worthy of being awarded the degree of Doctor of Philosophy. I'd like to say congratulate everyone today with such a brilliant speech, I think, from Meraryslan, from author of the dissertation. And again, I'd like to say thanks, lots of thanks to all members of council for so many and absolutely good questions to the candidate. Thank you very much for your attention.
Thank you, Paul. Okay, do we have your supervisor, Dr. Agiri? Yeah, thank you. The floor is yours.
Hi
please.
everyone. Sorry, it's a little bit late in our time, but I was very pleased to hear Meraryslan and present his work to everyone. I would like to say that my main goal working with Meraryslan was to see that he's going to grow as an independent researcher, not a person who's just going to have a title of PhD dissertation or anything like that, but I first of all would like to see him being an independent thinker who can contribute intellectually to our field. And throughout these 3 years that we have worked together, I have got really convinced that he achieved that state. So this is just the beginning of his academic career when he approached the very challenging problems. This problem that he tried to solve here at PD is any hard problem, so it means there is no exact solution available, and we are only limited to heuristic solutions. And he was able to develop a model and approaches that solve this very challenging problem. And we published 2 papers, and we also worked on a scientific grant for this project. And throughout that process, Meraryslan has been extremely helpful. And I'm very grateful for all his valuable insights, how support that he has shown in working together. And I truly believe that he deserves the title of PhD. So that's it from my side. Thank you.
Thank you very much, Professor. Thank you. So then we can move to the next stage, the discussion of the dissertation. So the first, we would like to hear from official reviewers, Lezat Bolatovna Playeva. Please, Lezat one. Right there, yeah. Microphone. Please, you should turn on the microphone. Микрофон қоссаңыз.
Здравствуйте, уважаемые коллеги. Спасибо за возможность представить рецензию. Значит, рецензия дана на работу Мералиева Мерарыслана Руслановича, выполнена на тему нейронная комбинированная оптимизация для маршрутизации транспортных средств с использованием дронов. Работа выполнена в рамках проекта «Решение на основе искусственного интеллекта для современной городской логистики». Диссертационная работа направлена на разработку оптимальных алгоритмов для доставки последней мили. Используются современные методы машинного обучения, в частности, обучение с подкреплением. Диссертационная работа Мералиева является самостоятельной научной работой, инновационными решениями. В работе проведен полный аналитический обзор с ссылками на источник проведенной литературы. В экспериментальной части используются современные методы машинного обучения, в частности, обучение с подкреплением. По полученным данным проведены сравнительные показатели для оценки эффективности разрабатываемых моделей и алгоритмов, включая сравнение скорости, доставки времени, разработка решения. Значит, представленные результаты демонстрируют превосходство предложенного подхода методами решения логистики в условиях динамически сложенных сценариев. Данная работа направлена на расширение задач масштабируемых и эффективных решений для доставки в расширяющем секторе электронной коммерции, особенно в задачах последней мили. Значит, в работе приведены исследования интеграции дронов системы доставки, предлагается структура оптимальной доставки на последней миле, используются современные алгоритмы машинного обучения, в частности, обучение с подкреплением. Данное исследование предлагает инновационные методы оптимизации маршрутов доставки. Результат этого исследования дает возможность казахстанскому рынку повысить конкурентоспособность. Данная интеграция дает возможность масштабируемость для разных регионов. Данная диссертационная работа состоит из нормативных ссылок, сокращенных слов, введения и также 4 основных глав. Также заключение и список используемых источников. Изложение материалов является структурированным, понятным, четким фокусом на исследование. Название основных глав раскрывает суть изложенного материала в главах. Название глав перекликается с поставленными задачами и отражает тему диссертации. Заключение сделано по поставленным задачам исследования диссертационной работы. Источник используемой литературы соответствует требованиям исследования. Цель диссертационной работы Цель диссертационной работы соответствует теме диссертационной работы. В работе также не полностью раскрывается оценка надежности доставки, показанная в цели. Цель диссертационной работы соответствует поставленным задачам и поддерживает единство с презентацией работы. Данная работа состоит из 4 глав, как я уже сказала, заключений и списка литературы. Введение автор определяет цель работы, актуальность, ставит задачи, также обосновывает новизну представленной работы. Аннотация самой диссертационной работы, теоретическая и практическая значимость работы раскрыта в отдельном пункте. Значит, в диссертационной работе представлены сравнительный анализ алгоритмов работы с известными используемыми источниками и системой интеграции дронов для маршрутизации транспортных средств. Результаты анализа представлены в виде таблицы и графиков, что обеспечивает наглядное, понятное представление эффективности предложенных решений для различных сценариев. Проведен анализ работы существующих систем маршрутизации транспортных средств, включая как традиционные подходы, так и системы интеграции дронов. Рассмотрены преимущества и недостатки известных методов, включая ограниченную гибкость, долгое время маршрутизации и неприспособленность адаптации динамических изменений в реальном времени. Представлена также разработка структуры алгоритмы работы марковского принципа принятия решений для маршрутизации транспортных средств с дронами, значит, позволяющий эффективно моделировать и оптимизировать процессы доставки. Разработана описана архитектура модели глубокого обучения с подкреплением, адаптированная к задаче VRPD. Модель учитывает специфику маршрутизации и интеграции дронов и обеспечивает оптимизацию процессов доставки. Также проведен сравнительный анализ гиперпараметров предлагаемых архитектур, включая время представления решений и точность решения результатов анализа, представленных в виде графиков, наглядно демонстрирует точность моделей, а также сравнение с традиционными подходами. В описании научной новизны подробно выделены алгоритмы машинного обучения, предлагаемые к защите, включая их уникальные аспекты, оптимизацию маршрутов и адаптивные подходы к динамическим сценариям. Сравнительный анализ результатов демонстрирует предложенные методы на основе глубокого обучения с подкреплением, значит, что существенно превосходят традиционные методы. Эти все данные приведены и проведен сравнительный анализ для отдельных узлов, для 8 узлов, для 10 узлов, и, значит, полученные результаты подкреплены процентным соотношением по повышению. Таким образом, определено, что РЛ-модель не только содержит временные ресурсные затраты, но и демонстрирует улучшенную точность в сравнении с существующими подходами. На основе представленной таблицы методы на основе РЛ особенно демонстрируют значительное превосходство над традиционными подходами, тоже определены по отдельным узлам и подкреплены процентными соотношениями в улучшении. Эти данные подтверждают, что РЛ-модель обеспечивает экономию затрат времени до 10%, и минимальное отклонение демонстрирует их эффективность и новизну в решении задач. Необходимо, значит, при обосновании актуальной работы рассмотрены основные маршрутизации транспортных средств с использованием без использования дронов. Определяется, что необходимо более глубоко исследовать алгоритмы нейронного управления, также привести алгоритмы и структуру технологии обучения с подкреплением. Предложенная задача подтверждается экспериментально, теоретически обоснованные подтверждаются результаты экспериментов. Исследования эксперименты проводятся с применением инновационных и современных методов. Выносимые на защиту результаты решения Мералиева являются новыми, также не опубликовались ранее в других работах или литературой. И по теме диссертации опубликована одна статья в журнале Scopus с процентилем 94. Автор провел глубокий аналитический обзор исследуемой темы, обосновал необходимые методы и алгоритмы для проведения эксперимента тестирования, глубокое обучение с подкреплением, также использование архитектуры трансферов. И основные результаты, выносимые на защиту, подтверждены экспериментальными данными. И, соответственно, для методов РЛ-гриди демонстрируются затраты в процентном соотношении для разных узлов. Показаны улучшенные показатели, и они подтверждены в процентном соотношении. Также проведен сравнительный анализ на то, что преимущество Ensemble RL на точность, затраты эффективности решения сложных логистических задач. Эти результаты подтверждаются высокий уровень научной новизны и практической значимости, достигаемых за счет использования современных методов машинного обучения для оптимизации маршрутов транспортных средств и с дронами. Теоретические гипотезы подтверждаются результатами данных тестирования системы оптимизации маршрутизации с использованием дронов. В диссертационной работе используются современные методы машинного обучения и алгоритмы включения и применение данных алгоритмов подтверждены ссылками и на актуальность и достоверную научную литературу, что подтверждает соответствие современным научным подходам надежности предложенных решений в задачах маршрутизации транспортных средств с использованием дронов. Значит, при выполнении диссертационной работы диссертантом проведен обзор 136 научных источников литературы. Это является достаточным для литературного обзора диссертационной темы, и автор подтвердил свою разносторонность по данному исследованию. В работе проведено систематическое исследование по методам машинного обучения и алгоритмов, также глубокое обучение с подкреплением с использованием архитектуры трансферов. Также алгоритмы построения решения и предлагаемые данные диссертационные представляют методы решения сложной современной логистики доставки. Результаты исследования дают возможность масштабирования и эффективного решения современной проблемы. Предлагаемые структуры алгоритмы дают решение оптимизации для задачи маршрутизации транспортных средств с использованием дронов с применением нейронных комбинированных алгоритмов на последней миле. Глубокое обучение с подкреплением, с применением архитектуры транспорта. Диссертационная работа написана в научно-техническом стиле. В работе приведены ссылки на научные источники. В работе имеются также стилистические ошибки. Значит, по заключению, диссертация хорошо структурирована, затрагивает важную тему, однако есть небольшие доработки, которые могут повысить ее качество и значимость. Одним из предложений является более глубокое обсуждение алгоритмов нейронного управления, что обогатило бы теоретическую основу без необходимости значительных изменений и, соответственно, корректировка стиля для обеспечения последовательности академического языка и формирования повысила бы читаемость работы. Небольшой расширенный критический анализ за счет дополнительных сравнений с традиционными алгоритмами позволило бы более продемонстрировать преимущества предлагаемых методов. Для будущих исследований рекомендуется изучить масштабируемость алгоритмов на более крупных наборах данных и сложных логистических сетях. Заключение. Замечания и предложения все не уменьшают важности научной ценности представленных диссертационных результатов. Исследование эффективно достигает поставленной задачи и предлагает инновационные решения для маршрутизации транспортных средств с использованием дронов. Хотя дальнейшее изучение алгоритмов управления могло бы дать более ценности, используемые методы являются творческими, хорошо разработанными и соответствуют задачам исследования. Диссертационная работа демонстрирует высокий уровень академической и надежности методологических подходов. Диссертация удовлетворяет требованиям для присуждения степени PhD, демонстрируя оригинальность, научную глубизну и актуальность данной работы. Используемые современные методы машинного обучения, такие как глубокое обучение с подкреплением и архитектура трансформера, подчеркивает значимость данной работы. На основании данного анализа я рекомендую присвоить Мерарислану степень доктора PhD по специальности 6D07-0400 вычислительной техники и программное обеспечение. Спасибо за внимание.
Спасибо большое. I think that we need short translation of the speech, right?
Okay, yes, dear committee members, you have the translated version of this review, but shortly. She said that the dissertation structures consist of 4 chapters, and it also includes very demonstrative tables and graphs, and which makes easy to understand the comparative analysis made by the author. And in this dissertation, you can find the pros and cons of existing systems of delivery and its analysis. Also, here in this dissertation, the author used the development of MDP methods with drone delivery, and this dissertation, I think, significantly can contribute to the logistics sphere of Kazakhstan and develop it further. Here also, the focus on RL method, reinforcement learning method, deep reinforcement learning methods was discussed, and the algorithms of machine learning to optimize delivery sphere, delivery systems, and computer analysis and the suggested methods were very effective. And he also mentioned the main highlights is that RL model demonstrates its effectiveness in terms of cost and time saving by 10%. So here also you can see that the candidate for PhD published his article in Scopus, which is 94 percentile, And considering all these requirements, in conclusion, she suggested to give the PhD for the candidate, and she said that she is confidently recommend awarding Meraryslan Meraliyev the degree of Doctor of Philosophy in the specialty of computer systems and software.
Candidate, please, do you have any response?
Yeah, I want to say thank you for official reviewer, and all the comments and recommendations will be considered in the future works. And regarding the comments, that comments will be considered in future works, and all the mentioned comments will be fixed.
Thank you.
Thank you.
The next speaker is a second official reviewer, PhD in 60-070300 Information Systems, Orkin Jumaranovich Mamurbayev. Please, Orkin Mirza.
Саламатсыздар ма, құрметті әріптестер. Давайте я зачитаю свою рецензию вкратце, потому что я официально дал, он на сайте есть как раз. Начну. Тема диссертации соответствует направлению информационно-коммуникационные космические технологии. Данная диссертация выполнена в рамках проекта, уже говорят, что уже соответствует направлению. Важность для науки. Ну, конечно, вносит хороший вклад, потому что разработанная модель, оптимизация маршрутов на сегодняшний день очень актуальная тема и помогает улучшать работу биоинформационной системы. Следующее. Принципом самостоятельности высокий. Диссертация демонстрирует сильные навыки написания и высокий уровень самостоятельности. Автор эффективно сочетывает сложности идеи и методы. Вы видели, что уже разработанный метод, уже был сделан сравнительный анализ и хорошие выводы. Следующее. Принцип внутреннего единства. Это обоснованно. Вы видели, каждая задача решает параллельно и носит хороший вклад и опубликована уже в хороших журналах. Работа соответствует глобальным изменениям в области цифровых технологий, целенаправленное на решение логических проблем Казахстана. Следующее. Содержание диссертации отражает тему диссертации, Диссертация четко определяет свою тему, исследуя как технологию дронов и обучение с прикреплением задачи маршрутизации транспортных средств дронами, наблюдение для мониторинга. Следующее. Цель и задачи соответствуют теме. Конечно, соответствует. Цели и задачи диссертации хорошо согласуются с ее тематикой, которая посвящена решению задачи маршрутизации транспортных средств и дронами. Здесь применяет модели оптимизации, построение оптимальных маршрутов, определение определенных примитивных параметров, и из него идет получается хорошие нейросетевые модели. Следующее. Все разделы положения диссертации логически взаимосвязаны, полностью взаимосвязаны, потому что вы видите, сперва был сделан хороший анализ, второй собран нужный датасет, к нему был построен модель, и когда модель была оптимизирована по методам оптимизации. Следующий. 4.5. Предложение авторами новые решения. Конечно, есть критический анализ. Если здесь он сперва сделал анализ по существующим методам и доказывает, уже разрабатывает свой алгоритм и методы, из него он показывает его эффективность. Научные результаты и положение являются новым, полностью новый, потому что полученный результат уже был опубликован в международных журналах, которые входят в Web Science и Scopus, и это и доказывает. Выводы диссертации являются новыми. Выводы данной диссертации представляют новые идеи, основанные на использовании транспортной сети для улучшения решения задачи маршрутизации. Исследование демонстрирует, как механизм внимания и эффективности управляет взаимодействием дронами и транспортным средством, предполагая маршрутизирование и построение траекторий. Технические и технологические, экономические, частично новые, потому что здесь есть уже решенные задачи, к этим задачам он добавляет свои данные. Из этих данных он совместно комбинирует, оптимизирует данные методы. Является либо тривиальным. Нет, диссертация представляет применение в транспортных сетях. На сегодняшний вы видите городские пробки, из него вот данная модель, если применить, то он показывает хорошую эффективность. Является ли новыми? Ну, результаты являются, конечно, новыми, потому что есть сравнительный анализ и выхлопы. Статьи, которые по требованиям уже первый рецензент почитал, по требованиям уже соответствуют. Рассматривая все эти сути, я докладываю, не попытаюсь своих замечаний. Хотя диссертация представляет собой хорошее структурированное и всестороннее исследование, в существенном вкладе в области оптимизации логистики существует несколько аспектов, которые могут еще больше усилить и влиять применимость. Значит, можно еще дополнительными параметрами оптимизировать данную модель или алгоритм. Но в настоящее время то, что он доказал, тоже результат. Значительные стилистические ошибки. Конечно, в диссертациях есть свои стилистические ошибки, но это не снижает значимость данной работы. Ну, в заключение я хочу сказать, диссертация соответствует требованиям для защиты на соискание степени доктора философии PhD. Она отражает высокий уровень научной строгости, оригинальности и актуальности в рамках выбранной специальности. На основании тщательного проведенного исследования и его результатов я с уверенностью рекомендую присвоить Мералиеву Мерарyslanу степень доктора философии PhD по специальности 6.07.04.00 вычислительные системы и программное обеспечение. Коллеги, спасибо большое за внимание.
We need short translation of that.
Okay, so briefly, the dissertation was carried out within the framework of the project under the priority information communications and space technologies, and this dissertation makes an important contribution to the field of logistics by presenting new ways to solve a vehicle routing problem with drones. Dissertation shows strong writing skills of the author and high degree of independence, and it is relevant and well supported, addressing important issues in e-commerce, logistics, particularly last mile delivery, which is crucial for customer satisfaction. And the dissertation clearly defines its topic by exploring how drone technology and reinforcement learning can solve the vehicle routing problem with drones, VRPD. So the goals and objectives of the dissertation align well with its topic, which is solving VRP problems with drones. And the dissertation is well organized, making it easy to follow. Each chapter builds on the one before it. It starts with an introduction, literature review that explains why the problem is important. So dissertation critically examines new solutions using reinforcement learning and drone integration for the vehicle routing problem with drones, and it presents new scientific results and methods to solve this VRPD. The author uses transformer networks to create advanced attention-based models that optimize delivery routes efficiently and at scale. So, taking into account all these recommendations, reviewer makes some recommendations. While the dissertation is a well-structured and a comprehensive study with scientific contributions to the field of logistics optimization, there are some few areas for improvement that could further enhance its impact and applicability. So in conclusion, the dissertation meets requirements for submission of the PhD degree. So it reflects a high level of academic rigor, originality, and relevance to the specialty. Based on a thorough analysis of the research and its findings, review confidently recommends awarding Meraryslan Meraliyev the degree of Doctor of Philosophy in the specialty Computing Systems and Software.
Okay, thank you very much, candidate.
Yeah, I want to say thank you for the official reviewer, and I want to make sure that all these comments will be addressed in the future works. So yeah, we'll continue to work in this direction.
Thank you. So, dear members of the dissertation council, we move to the next stage. So the discussion of this dissertation. So we had some questions, we had some answers. Now maybe some committee members would like to express their opinions. Yeah, anyone like to start? Maybe we need to, I would ask Professor Mansourova Madina to express your opinions. Microphone.
Thank you very much, dear colleagues. I think this topic is very actual nowadays because we say about digitalization in Russian civilization. We saw in this defense meeting that our doctoral student is ready to be one of the leading researchers in this university in our country, and I hear the recommendations of my colleagues and I agree, and I hope this doctoral student should continue his research work and get the new results. Thank you.
Thank you very much. Maybe others?
Yes, I support him in this work, and I recommend to receive the degree of doctor of PhD doctor.
Thank you very much. Okay. Others? Maybe Malcolm Smayov Nurjigit, Professor, can you say some words? Nurjigit Mirza, sizde bir tındasak болады ма?
Дауысым естіліп тұр ма?
Иә, естіліп тұр.
Құрметті әріптестер, өте керемет тақырыптың бүгін талқылауына түскеніне мен қатысқаныма өте қуаныштымын. Дегенмен де осындай модельдерді болашақта тағы да технологиялардың дамуына байланысты, арақашықтықтарына байланысты, яғни Алматы қаласының өзінде қаншама зейнеткер адамдар бар, оларға жаңағы қолжетімді болу үшін сондай дронды қажетті түрде жеткізу жағынан жасау және де докторантты болашақта PhD доктор дәрежесін алуға лайықты деп санаймын. Сәттілік барлықтарыңызға.
Рахмет сізге.
Dear colleagues, I'm happy to participate in this meeting because we are discussing very topical issues, and the topic of dissertation is very important in delivering different kind of goods in different parts. Even particularly in Almaty, we have a lot of retired people and a vulnerable part of our society, and I think this technology will help them to deliver necessary goods. So I think the given candidate is recommended to get the title degree of Doctor of Philosophy. Thank you.
Maybe Professor Mohammed, you would like to say some words?
Yeah, so actually, thank you for your great work, and as you saw, like all of them are happy with your work. So I would like to congratulate you for research. And I wish you like the best of luck with your endeavors.
Thank you. Maybe some other people would like to make a speech? No? Okay. So I will just say my words then. So we have seen very long presentation and thorough questions and all the answers. I believe this really displays the proficiency of our candidate today, and I support him, so wish you best. Thank you. So if there's no questions, we'll move to the next part. Dear council members, according to the regulation, we now proceed to the secret voting procedure. To conduct this procedure, we need to elect the counting commission. So we propose to elect this counting commission in the form of Smailov Nurjigit Mirza, Mansourova Madina and Utbayeva Dana. Do we have any objections on that? No? Okay, thank you. So we elect this commission. So now we need to make a voting, right?
members, we have sent over the online link for voting. Please, could you vote to that link?
So our secret voting have been conducted. We have results. Our chairman of the voting committee is Professor Meraryslan Meraliyev, but we would ask Dana Utibayeva to announce the results. So please, the floor is yours.
Рахмет. Есептеу комиссиясының бірінші хаттамасы 31 қаңтар 25 жыл. Есептеу комиссиясының құрамы төрағасы Исмаилов, мүшелері Мансурова Мадина ханым және мен. Есептеу комиссиясы Мералиев Мерарyslan Meraliевичке 6-07-04-00 есептеу техникасы және бағдарламалық қамтамасыз ету мамандығы бойынша философия докторы дәрежесін алу үшін Neural Combinatorial Optimization for Vehicle Routing Problem with Drones деген тақырыбында диссертация қорғау бойынша жасырын дауыс беру нәтижелерін үшін сайланды. Және кеңес мәжілісіне 6 кеңес мүшесі, оның ішінде қаралып отырған диссертация саласы бойынша 4 ғылым докторы, PhD-лар қатысты. Жасырын дауыс беруге 2 ресми рецензенттер қатысты. Олардың дауыстары диссертациялық кеңес мүшелерінің дауыстарына тең. Жасырын дауыс беру электронды форматта өткізілді. Толтырылған электрондық бюллетендердің саны 8, жарамсыз бюллетендер саны 0. Жалпы дауыс беру нәтижесі философия докторы PhD немесе бейіні бойынша ғылыми дәрежесін беру бойынша 8 дауыс, яғни барлығы дауыс берді. Сондай-ақ ғылым дәрежесі PhD философия докторы дәрежесін алу үшін біздің кеңес комитетке жолдайды.
Who is in favor for approving this protocol?
Yeah.
So first of all, we need to officially approve this protocol. Do you in favor to approve? 6 for the agrees, 8 agrees, 0 against. Yeah, we agree. Thank you. So, none, any objection? The protocol's county commission is approved anonymously. Thank you. The dissertation concept for the education program 6D070400 computer system and software at the university based on the public defense of the dissertation of Meraryslan Meraliyev on the topic of neural combinatorial optimization for vehicle routing problem with drones has decided to petition the committee for the awarding of the degree of Doctor of Philosophy PhD or Doctor of Science and Profile. Thank you. Congratulations, candidate. Thank you very much, everyone. So that's it. We are finishing our consult. Yeah? So this way we can close our meeting for today. Thank you very much.